Alright guys, in this video we're going to go over displaying quantitative data. So you can get this from me in class, you just have to ask me for it. So question number 1, go ahead and read it and see if you can pick out the best answer. So because it looks like there might be an outlier over here, this data is skewed to the right. The outlier is what skews the data. So it's definitely not B, D, or E. So now we have to compare the centers. Centered at about 8. So do we think this is the center, or do we think this is the center? So 4.5 looks like the best center. 8 does not look like it has the same amount of data on the right and on the left. And usually with a histogram, when we're talking about the center, we're referring to the median. We cannot calculate the exact mean because we don't know what these numbers exactly are. So C. All right, read question 2 and see if you can pick the best answer. So standard deviation describes how spread apart the data is. So a big standard deviation means a big range. A smaller standard deviation means a smaller range. So if I were to take this outlier and put it where the rest of the 29s are, here's 29. When you're making a histogram, equal or bigger goes into the following bin. So that would put it here. So what's going to happen to the mean? I just took away the biggest answer and put it more close to the middle of the graph. So my mean is going to get smaller. My average is going to get smaller. So it's not A, and I really don't see how C, D, and E could be possible because you're taking the largest number out of the data set. So the mean is going to decrease. And the standard deviation would also decrease because I'm not as spread out as I was when I had to go all the way up to this point. So B makes the most sense. All right, read question number 3 and pick the best answer. So when you're deciding how to compare the mean and the median, it's based on the shape. So in a normal curve, normal data, your mean and your median are going to be about the same. When your data is skewed to the right, the mean is highly influenced by the outlier. So if an outlier is pulling your data to the right, your mean follows it. The median is always going to be centered where most of your data is. It's resistant to the outlier. So the median is going to be smaller than the mean when it's skewed to the right. And oppositely, when it's skewed to the left, the mean is getting pulled to the left. Your median is going to stay with the rest of the data. So based on which one of these is bigger is how we can get an answer. So when you have a stem and leaf plot, just be careful because you have a vertical display. And usually when we're describing skew, we know the smaller numbers are on the left and the bigger numbers are on the right. So just keep that in mind that this is going from 11 to 17. And if I read the key, 17-9 means 179. So this means I have 116 and I also have a 118. I have a 121, a 124, and a 128. And then I have a 179 all the way down here. And you can see there's a gap. So 179 is probably an outlier. Most of my data is up here. So this is probably a little bit skewed to the right. So if you need to adjust your answer, I'll let you pick a new answer. All right, so the mean is greater than the median. We would never compare the standard deviation and the mean. We're not going to compare the standard deviation to the median. We could compare the standard deviation and the range, but they don't really tell us the same thing. Standard deviation describes the distance from the mean. Range is just the high minus the low. So we don't typically compare those either. All right, read question number 4 and determine the best answer. So I would eliminate A because when you're deciding if a box plot is skewed, we usually look at the box and how balanced the median is. And this one looks very balanced. So this seems pretty normal. So I would eliminate A. So let's check B. The median house price in Dublin is higher than the 75th percentile of the house price in Westerville. So remember, each section of a box plot is a percentile of 25. So Westerville's 75th percentile is at the end of Q3. Q3 is the 75th percentile. And I can see that that is actually less than the median of Dublin. So the median house price in Dublin is higher than the 75th percentile. That is true. We would not use a box plot to compare the mean because this is just the percent of the numbers in the data. All this tells us is the median and the quartiles. And half of the houses sold in Westerville cost less than the cheapest 25% of houses. This is the cheapest 25% of houses for Dublin. And that's not quite half. It's only about a quarter. It's almost actually the same. They almost line up. And the range is about 1.5 times the range. I mean, you could calculate that and figure it out, but B seems to make the most sense. All right, so this one we will do together. Part of your redo questions, you're going to have to turn in your own sample. So this one is asking us to compare the distributions of travel times. So when you're asked to compare distributions, we are looking for all of those to be met. The center, unusual features, the shape, and the spread. So you can have a variety of different sentences, but you have to hit those key marks. So we can estimate the median from a histogram, but I would stay away from mean. We do not know the exact values, so the mean would not be accurate to calculate. On a dot plot, you can do the mean. On a stem and leaf plot, you can do the mean, but not on a histogram. So we can kind of estimate, this is 32-ish, maybe that's 22, maybe that's 1, maybe that's 18. And so we can figure out how many are in each, and it tells us that there are 61 workers. So the median, you know, we have to have 50% of the numbers on this side, and then the median, and then 50% of the data on that side. So if I have 30 and 30, and then 1 in the middle, that would be a total of 61. So it looks like the median is probably somewhere in that bin for Los Angeles. But I won't get to 30 probably until here for New York. So it looks like the median for Los Angeles is from about 0 to 20 minutes, somewhere in there, whereas the median for New York is bigger, somewhere between 20 and 40 minutes. Any unusual features? It doesn't really look like, I mean, I wouldn't even necessarily call that an outlier because there's not like a gap or anything, but you could just say there are no unusual features, or you could say both graphs are unimodal, or there's a mode somewhere in this first bin for both of them. The shape, you would want to describe the shape of both of them. So this first one is skewed to the right, whereas the New York seems a bit more uniform, or you could say roughly normal. Basically, if it's not clearly skewed, you can say approximately normal. So those are basically going to be your options. Skewed left, skewed right, or you could say approximately normal. Or you could say uniform. This is not exactly uniform because they're not all exactly the same height. But as long as you use an adjective like roughly or approximately, you can probably get away with it. All right, and then the spread of the data. For this, we could do the range. It would be hard for us to calculate the interquartile range because we don't have these exact values. But range, interquartile range, standard deviation, those are all ways that you could describe the spread. So the spread is the same. The data varies from 0 to 100 minutes for both. So they have the same spread. They have the same variability. All right, but when you see the word compare, that's what it's referring to.